Hello, everybody, and welcome to our webinar here today. This is going to be part 3 of our FES sessions that we've been having over the last couple of weeks or months now on designing a roundabout and modeling a cul de sac in Civil 3D 2025. Very excited to have Doug Medley here presenting today and to be here, representing FES. So a couple of logistics to go ahead and get us started here. All attendee lines will be muted throughout this presentation. Send us your questions via the chat box or the questions box, and we will be answering those during the Q&A session at the end, but go ahead and send those over to us when you think of them. The webcast will be recorded, and you will receive an email link if you're registered to be here today after the session, usually an hour or two after the session, with that recording. Any questions, concerns, anything of that nature, you can give us a call at 305-445-6480 or email us at info@ddscad.com. All right, so before Doug goes ahead and gets started, we are going to turn it over here to Tej, representing FES, to say a couple of words. Go ahead, Tej.
Hello, everyone. Welcome to everyone to our session 3 and our last one in this series for this year at least. Just wanted to share a couple of updates from what's going on with FES before I introduce our amazing presenter for today. If we can move on to the next slide. Yes, so again, yes, of course, I'll just quickly share about the upcoming events and thank our sponsors and then hand it over to, so of course, like nothing is possible without our sponsors. These are our platinum annual sponsors, so thanking each one of them and moving on to our gold sponsors, and then also our silver sponsors. And DDSCAD, who is actually courteous enough to be doing this series for us, is also one of our annual sponsors. Thank you for your great support all throughout. For some of the upcoming events, before I go there, we also like to thank our student chapters. We have 4 student chapters, and I know a lot of the students who are registered for this and taking good benefit of this series which we are doing, the Civil 3D series. So thanks to all our students chapters too for the great work they do and for staying engaged. What we have upcoming is on June 10th is a District 6 work program with FDOT which we are doing, and we will be having the presence of the District 6 Secretary Danny Iglesias and the Director Rudy Garcia, and also hopefully the new director which will be appointed soon for the transportation development. So look forward for this. If you have not already registered for it, we are getting full very soon. So if you are interested in being part of this event, please use this QR code to register for this event. Also in July, we are planning a Miami-Dade County work program and have already coordinated with, we'll mostly have Director Stacy Miller and Assistant Directors Sale and Maria Perdomo, but we have not finalized the date yet, so be on a lookout for the date for that. And after that, in August, we'll be having our FES Miami New Board 2025 and 26 installation, as well as the scholarship awards, where we do award scholarships to high school and university students. So be on a lookout for that as well. And without any further ado, I would like to introduce our wonderful presenter, Doug Medley. I'm sure he will share more with you as we move forward, but little bit what I understand and know about him is his expertise is to do a lot to do with Autodesk products, one of which he'll be talking about today. 35 plus years of experience, and also he's done numerous presentations in different platforms in FDOT Civil 3 trainings, with FDOT, with the Design Expo, with FLUG. I know a lot of you might be attending FLUG and might not be aware of it. So let's welcome our amazing presenter, Doug Medley, and let's hear it from him.
Thank you, Tej. Again, I'm Doug Medley. I'm an infrastructure support specialist with DDSCAD. So again, welcome to today's FES webinar number 3. We're going to be talking about designing a roundabout and modeling a cul de sac in Civil 3D 2025. And if time permits, I may actually be able to show you something else, but I'll leave that till we get to that part of the presentation. So today we're going to be talking about understanding roundabouts in Civil 3D 2025. So I've kind of broke it down to talk about roundabouts Civil 3D enhancements for roundabouts, and about the heads-up display that's used when we're creating roundabouts in Civil 3D. And then I'm going to actually do an actual live roundabout, and I'm going to create a cul de sac as well. So Civil 3D 2025 roundabouts can be modeled according to defined standards. Now, the terminology varies around the world, but roundabouts can be modeled either normal or compact. Civil 3D 25 creates roundabouts that blend with existing or planned roads. The point on each incoming road or arm at which the roundabout model starts is called the blending point. So if you have 4 roads leading into a roundabout, you're going to have 4 blending points. Now, once placed, every aspect of your roundabout model, including the location of the blending points, can be edited either using grips or using the properties dialog box. Now, the default geometry of your roundabout is determined by the standard that you use, and we'll talk more about standards here in a bit. The standards that are applied with Civil 3D are locked to prevent the accidental or intentional changes, but you can create your own, and these can be password protected. Now, these standards define the limits for each of the geometric values. The values can be unlimited. As you adjust your roundabout model, Civil 3D checks that geometry against these limits and displays an immediate warning if a value goes outside the specified range. That's very similar to like if you're creating an alignment and you've got design check turned on and you picked a particular standard you want to use, and if you have a radius that's too big or too small, you get that little symbol on the screen. So we're kind of talking about the same type of technology. Now, these warnings are also used by the design check tool, and you're able to enter a justification for a transgression in there. But today we're not going to get into that design check tool, but know that it is available to you. Now, the appearance of the roundabout, the line colors, the styles, the thicknesses is all controlled by a style. And as we all know about Civil 3D, it is a style-based application. Now, roundabouts are becoming very popular in the state of Florida. Many existing intersections are being upgraded to roundabout designs. Now, Autodesk has an application called Autodesk Vehicle Tracking, which is part of your any of those who have the AEC collection. If you have plain Civil 3D, you don't get access to the Autodesk Vehicle Tracking application, but if you have the AEC collection, then you have this Autodesk Vehicle Tracking application available to you. And it has a robust set of tools for the creation of roundabouts. Now, the roundabout tools within Civil 3D 2025 are a subset of the Autodesk Vehicle Tracking tools. When roundabouts in Civil 3D are created, there's some extra functionality that doesn't exist in the vehicle tracking application that allows you to construct part or all of a 3D corridor model. And we'll talk about that more in a little bit. Civil 3D has features to simplify the preliminary layout of a roundabout geometry. And that's what we're talking about. We're using this tool to create your preliminary layout as an engineer or designer of a roundabout design. Now, the editing options are also available, and as you make changes to the layout, you'll see the dynamic functionality of the objects as well as the adherence to design standards. Now, just like Civil 3D, when you're doing an intersection or you're creating a corridor model and you make a change to it, they dynamically update. Now, Civil 3D 25 can optionally create the following. It can create horizontal alignments along each near side or offset definition line for the ICD, the apron, the island, and the circulatory area crown line. Vertical profiles along the alignments, and it can create a 3D corridor model using the provided assemblies as long as certain conditions are met, and we'll talk about those conditions in a bit. Now, the creation of these objects when a vertical tracking junction initially is created is controlled by the corridor drawing settings. Once that junction has been created, it's then controlled by the corridor junction properties. Now, Civil 3D may be configured so that every time a roundabout geometry is created, these alignments, profiles, and corridors automatically rebuilt. Now, I believe that's a default. Now, the roundabout object is also linked to the polylines to the alignments on which it is based. So if you create a roundabout based upon an existing Civil 3D alignment, then the roundabout updates automatically when you move these alignments around. This function allows you to build an Autodesk Civil 3D roundabout into an existing corridor model and have them behave like a Civil 3D intersection object. Now, All roundabouts are created in accordance with defined rules or standards. So when we go to create a roundabout, the first thing that's going to pop up is this Roundabout Standard Explorer. And this is where we would go in and find the standard that we want to use and the year we want to use, and then pick the roundabout design that we want to use when creating a roundabout. And we'll get into that in more detail as well. Now, when you create a roundabout and you start adding what we call a leg or an arm, you get this thing called the HUD, the heads-up display. So the heads-up display shows the critical design values related to each arm. By default, they appear adjacent to the arm, but they also can be displayed in a single table if you require. Each HUD has two grips. One allows you just to move it, the other one allows you to resize it. The color of the frame, the line style, and the thickness can be changed in the HUD style, and also what's displayed in the HUD as well. Now, we could spend a couple days going through all the properties and the values of how these roundabouts are created, but today we're going to talk about just a couple things: the design radii and speeds. Now, in the HUD, the displayed data is color-coded to allow you to have a quick interpretation. The critical design radii and speeds calculated by Civil 3D are shown green if they are within the limits specified in the standard, and red if you're outside of them. These values may also appear amber when they get close to a limiting value if the user has defined a proximity warning percentage. Now, we have these values R1 to R3 and V1 to V3. So R1 to R3 and the corresponding V1 to V3 relate to the through path through the roundabout. If there's no such path, then these values display as NA in the HUD. R4 and R5 and V4 and V5 relate to the 90-degree and the 270-degree turns respectively, and either of these is not present if the value is not displayed, will also be displayed in the HUD as NA. R1 to R5 are based upon the smooth fastest path line. Okay, now it's difficult to create the fastest path alignment consistently, so a common alternative is to calculate the path using the construction is more easily repeatable. Therefore, the R1 max value and the corresponding V1 max value are therefore based upon the largest radii arc that can fit tangent to the offset alignment at the start point on the approach road and tangent to the offset circle in the circulatory space. Okay, now there's a lot of things that you have to understand about that. So one of the things that I recommend that you do is that when you start playing around with the roundabouts, I would go into Google, go to help, and go to do a search on Autodesk vehicle tracking help if you don't have vehicle tracking installed, and get to the glossary, and you can get to all the terms about all these things. And we'll go over some of these terms in just a second. All right, now, some of the terms I extracted out of that glossary are these here. So here's basically what a HUD might look like. So we have like R1 to V1, R2 to V2, R3 to V3, R4, R5 to V5, all right? So the R1 is your entry path radius. It's the minimum radius of the fastest vehicle path or close to the entry yield line. The R1 max is the maximum entry path radius, and that is the maximum path radius, all right, that can be drawn tangent to the road alignment at the fastest path start offset and tangent to the offset circle in the circulatory area. R2 is the circulating path radius. That's the minimum radius of the fastest vehicle path around the center island. R3 is the exit path radius. That's the minimum radius of the fastest vehicle path at or close to the exit. All right, R4 is the 270-degree turn path radius. That's the minimum radius of the fastest vehicle path of the vehicle performing a 270-degree turn. R5 is the 90-degree turn path radius. That's the minimum radius of the fastest vehicle path of the vehicle performing a 90-degree turn. V1 is the entry path speed. That's the vehicle speed that corresponds to the entry path radius. And then V1 max is the maximum entry path speed, and that speed corresponds to the maximum entry path radius. Now, all this information came directly out of that glossary that I was telling you about. Okay, V2 is the circulating path speed, the speed that corresponds to the circulating path radius. V3 is the exit path speed. That's the speed that corresponds to the exit path radius. V4 is your 270-degree turn path speed, and that speed corresponds to the 270-degree turn path radius. And the last one is V5, which is your 90-degree turn path speed, and that speed corresponds to your 90-degree turn path rates. And so these are the things that are showing up in this HUD. And these things may show green, which means they're good. This means there may be amber, which means they may be getting close to exceeding, and they may be red, that means you've exceeded a value. Now, so the other things you may get is a geometric warning. So in some cases, when you move a grip or you change a value in the roundabout's properties dialog box, it may cause a warning triangle to be displayed, okay? Very similar again, like if you have an alignment and you're using a design check set and it basically has a radius is too big or too small, you get that little triangle. I kind of get the same thing here with roundabout design. Now these occur when a value goes outside the limits recommended by the adopted standard. Alongside the warning triangle is a short description of the problem is displayed. The visibility of the format of the short warning is controlled by the warning symbol style. All right. If there is a symbol within the triangle, it will provide additional information. For example, if you have a less than minus 304, that means that the inscribed circle diameter is 304, in this case, meters less than the minimum recommended of the standard. So you're just going to get these little warnings on your screen, all right? And these things can be turned on or off, all right? Now, if you don't see the warning triangles, that means you've got them switched off in your style editor. Now, the fastest path warning, even though the US standards require the checks of only R1 to R3 through the paths and only R4 on left turns and R5 on right turns, you know, the tracking software calculates the entry, the circulating, and the exit radii of all paths throughout the roundabout, okay? Now, to create a roundabout, you go to the Home tab, you go to the Create Design panel, you pull down the intersections, and that's where you're going to see the Create Roundabout tool. Now, below that, you have an approach, and you also have an option to configure a roundabout. The approach is where we wanted to add basically something that's going to bypass the roundabout. We're not going to cover that today, but that's something that you can do. You can put basically, I'm sorry, the approach is where you add a leg, okay? We can also go in and add a basically something that would tell us to bypass the roundabout. And also we can go in and configure our roundabout standards, all right? So we can create a roundabout from alignments, lines, or polylines, defining the alignment of incoming roads of the roundabout. The alignments do not need to intersect, and the same alignment can be used for two approaches in a roundabout. So typically you'll have two or more alignments drawn representing the approach roads. However, you may begin with one alignment, right? And then as you go back and add another alignment, then you can go back and use this add approach command to add an additional approach to your roundabout. And we'll talk about how we get to those tools here in a bit. All right, so creating a roundabout from alignment. So this little example here, I've got an alignment that doesn't intersect with this alignment. So I run the roundabout command. I select the standard that I want to use to base my calculations on. Once I've selected, I prompt for some other values. Then when I close that, it's going to ask me to start picking, you know, the legs of the roundabout. And that's where you'll go through and you start picking on these different alignments. And we'll do that here in just a second. All right. Now, after we had gone through that, where we had this alignment and this alignment, this is what was created in that roundabout tool. Now, in this example, it didn't create the corridor model because possibly these alignments didn't have a design profile yet. So when you have that condition, it does not create the corridor model. All right. Now, creating a corridor model from a roundabout. Using the roundabout properties that you set an existing ground surface, all right, from a drop-down list, or you pick it from the drawing. This creates a dynamic corridor in the drawing. The corridor automatically updates when the roundabout geometry is modified or the approaches are modified or added or deleted, okay? So I'll kind of briefly going to go through the steps to create a roundabout, and then we're going to actually do one. So you would go to the Home tab, the Create Design panel, intersection pop down, Create Roundabout. You get a dialog box. Then you'll go in and you enter a name and maybe some notes or a description. Then you tell it that you want to calculate the elevations to have the roundabout placed using the existing elevations. Then the ICD is the diameter of the definition line that represents the outer limit of the outer curve of the roundabout. Okay. The center island diameter is the island around which the vehicle is turned. Now, it does not include the apron or the overrun area. The apron diameter is the diameter of the overrun area. Then you tell it how many lanes you want for that roundabout, and it's going to have a default coming from that standard. You choose how you want the roundabout to be drawn. That's a style. Then you pick your existing surface. Now, the final surface is an option. So if you pick that, the final surface is the surface on which the objects can be projected. All right, so you select that from the list, all right, and then you go down here and you pick the next option that you want to project it onto the final surface, where it's actually going to be draped over that surface. Today, we're not going to use the final surface or the project plan. Now, once you've gone through all those things, you hit OK, you locate close to where you want the center of that roundabout to be, all right, over those two intersections, and then you start picking the legs or the arms of the roundabout. Once you're done with that, you hit enter, and it goes out and it creates the roundabout in your drawing. Okay, now, once that roundabout is created, when you go to your Prospector tab and you expand your alignments, underneath your center alignments, you're going to find your roundabout listed. Okay, so basically it's in the Prospector tab, and it's not a true roundabout collection. It's not like you have an intersection collection like we could have inside of our Prospector tab. The roundabouts are placed underneath, in this case, the center line alignments. And then you have each component that was created for that roundabout being listed. And we'll look at some of those in a bit. All right, now to create a roundabout, we use the roundabout tool. Now, but before you create a roundabout, there are some requirements, all right? And the requirement is Civil 3D existing and final surface. The final surface is an option. If no surfaces are available, then only a 2D roundabout is created without any corridor segments. Your alignments, profiles are optional, but if no profiles are available, then only a 2D roundabout will be created. All right, so let's jump over here into Civil 3D. All right, and let's create a roundabout. Now let's talk a little bit about what we have in this file. All right, now this is a part of a data set that I use in training classes. Now, in this drawing here, we have a couple of alignments. So if I hover over this alignment here, all right, this alignment here is Jeffries Ranch Road. If I hover over this alignment here, it is Rand Boulevard. So if I go to my alignments and I look under my centerline alignments and I look under Jeffries Ranch Road, you'll see that I have a design profile. So I have part of what I need. If I go down to Jeffries Ranch, or not Jeffries Ranch Road, but Rand Boulevard, and I expand out the profile, you'll see that I have a design profile for that. So I have in this drawing, I have a surface called existing site. So now that means I have the conditions. I have a surface, I have, in this case, my two alignments, and both of those alignments have design profiles. That means I can create a corridor model. Okay. Now in this drawing, I also have a couple corridors. So if I hover over this one here, right, this one here is going to be my Jeffries Ranch Road corridor model. And I hover over this up here, this is my Rand Boulevard. Now, when you're creating a roundabout, you want to do what I've done ahead of time here just to save time. Jeffries Ranch Road went all the way through here. And what I did was, and we did this last month, when we did the intersection, is I go up here and I basically split the region. So what I did was, is I split the region of this Jeffries Ranch corridor right here in the middle, and then I pulled this region back, and then I pulled this region back. And I did the same thing for the Rand Boulevard corridor. I split it and I pulled this region back and I pulled this region back. You do that so you have an area to place the roundabout. Right? I need that open space to be able to place the roundabout. And then when I'm done, I can go back and put all this stuff back together. So that's why we see what we have here. All right. So what we're going to do here now is we're going to zoom in here. All right. And I'm going to go up here and I'm going to pick a view that I've got saved to start with. So roundabout create. So what we're going to do here now is that we are going to go up to the Home tab. We're going to go to the Create Design panel. We're going to go to Intersections, and we're going to pick on the option Create a Roundabout. All right. So now, because I don't have a default standard set yet, I've got to pick the standard that I want to use. So I'm going to go down here and pick U.S. Junction Standards, U.S. Federal Highway Administration. I'm going to do the 2010 version, and I'm going to create a 2010 urban double lane roundabout. Now, if I make a default here, that's going to set that as the current default for the next roundabout that I may create, and I will not get this box. So I would have to go back up to my Home tab, Create Design, expand out my intersections, and I would pick on the option to go in and change my roundabout properties. Okay, but I'm going to hit Proceed. And then it's going to say, well, are you sure you don't want to make that the standard? No, I don't want that to be my standard. So the first thing that's popped up is this new roundabout details. So I'm going to go over here and I'm going to give this a name. It's going to be Jeffries Ranch and Rand BLVD, Rand Boulevard. Okay, I'm going to tell it to calculate elevations. This is the standard that I told that I wanted to use, and now it's reading in the ICD, right, value, the center island diameter, the apron width, right, and it's going to have 2 lanes. My appearance is the style that I'm going to use. I'll use the default style. My existing surface, I'm going to set as existing site. I'm not going to use a final surface, so I'm not going to project it. All right. So now I've answered the name of my roundabout. So I hit OK. Now it comes up here at my cursor. You'll see now that I've got what my roundabout's going to look like, at least for the circulatory area of it. So I'm going to take that and I'm just going to move it and put it approximately where I want that roundabout to go. I'll pick right there. Now, the first thing it's going to do is it's going to ask me to select the line defining the new access road. So I'm going to pick on this line right here. Now, the reason why I'm getting this little pop-up box is because I've got selection cycling turned on. So I'm going to pick on the alignment. So when it comes up, it's going to tell me the default name of that first arm or leg. It's going to take the elevation from that design profile from Jeffries Ranch Road. Now, this lane is going to be a 2-lane road. So I'm not going to have any central gap width. I'm going to have one approaching lane, and it's going to have a width of 15.5. I'm going to have one departing lane, and it's going to have a width of 15.5. And I'm going to hit OK. And now it gives me a preview of what it's going to look like. I'm going to go up and pick my next leg or arm. All right, I'm going to pick on this alignment. All right, so this one here is going to use the elevation from the Rand Boulevard design profile. All right, now this is going to be a divided highway, which has a gap of 26 feet. It's going to be 2 lanes approaching, and each lane is going to have a width of 12 feet. 2 lanes departing. Each lane is going to have a width of 12 feet. So I hit OK. Now I'm going to go over to pick on this alignment. All right, this is going to go back to a 2-lane road. So no central gap width, 1 lane coming in with a width of 15.5, and 1 lane going out, departing at a width of 15.5. And I'm going to hit OK. And I'm going to go now and I'm going to pick my last alignment for my last leg. All right, this one again is going to be a divided highway. So I'm going to type in 26, 2 lanes approaching with a width of 12, and 2 lanes departing with a width of 12. All right, now I hit OK. Now it's going to keep asking me to select more arms or legs. All right, I am done. So what I'm going to do is I'm going to zoom out a little bit, and now I hit enter, and now it's going to start creating the roundabout. Now it can take anywhere from 45 seconds to a minute, minute and a half, depending upon the speed of your machine, depending upon the complexity of your roundabout. All right. So what it's doing is going through and it's creating 2 things here. It's creating something called a vehicle tracking junction, and it's also going to be creating my actual 3D corridor model. So you can see you've got the barber pole in the lower right-hand corner of the screen, and it's just working away. All right. And there we go. I'm going to hit escape. All right. And there we go. There is a roundabout that's been designed based upon the parameters of that standard that I selected. Now, let's talk about what we have here. So the first thing here is if I go up here and I hover over this here, all right, and if I pick on it, that's going to select the corridor. So if I'm working here and I start editing any of these properties, I'm going to be editing the properties of the corridor that was created from that roundabout junction. That's not what I want to do right now. What I want to do is I want to go over here, and I can pick it a couple different ways. I'm going to find the easiest way, and I'm just going to go over and I'm going to select on this HUD. Now, this HUD right here is for the first arm, so you can see that I've got some of the values have come in as green, right? One of the values is amber. That means I'm approaching a limit. If I go over to this arm here, you'll see that I've got an issue with the radius 1 and the V1, which is the size and the speed. All right. If I go down here to this arm, this one looks good. And if I go down to this arm here, I have an issue with the speed and the V1 value, okay? Now, I'm just gonna select on any one of those HUDs. And you can see when I hover over it, it says this is a vehicle tracking junction, right? So when I select it, you'll see now up here in my ribbon, I get a tab that says Roundabout, all right? And then I get a modify panel that lets me add an approach, remove an approach. So if I want to remove an approach, I pick on any one of these approaches and it would be removed. I can add speed striping. I can remove speed striping. I can add this thing called the slip lane. I can remove a slip lane. I can add rubble strips when I'm entering into the roundabout. I can remove them. I can add a splitter island. I can add crosswalks, okay? Now, the one thing that I want to show you before I get in here, if I go in here again into my alignments, under my center line alignments, you'll see now that there's my roundabout, all right? So let me just hit escape real quick, just before we get in and change the properties. So when I pick on any one of these values here, and I right click and I say select, it will highlight the property that I'm modifying, that it was created automatically when the roundabout was created. If I go down here, maybe pick this one and I hit select, all right? So you can see that now I've got one of the radiuses coming out in here. If I expand it out, you'll see that it also has created the profiles. So everything that you see in the creation of this roundabout is being shown up underneath the alignments, under centerline alignments, underneath the roundabout name that we've created. All right. Now, let me go over here and let me select on that vehicle tracking junction. Release everything here before I select it. All right. There we go. So what I'm going to do is I'm going to go up here to my roundabout properties. So this is where I can go in and I can change the properties of my roundabout through tables, okay? Now, the first thing that you have to know about this application, that this portion wasn't created in the United States, and so it's got a little different flavor to it, so the wording may not match what we expect. It doesn't say roundabout, it says roundel. So if I expand it out and I pick on dimensions, it gives me the dimensions about the roundabout. And when I pick on any one of the boxes, I get a little graphic that shows me what I'm actually changing, all right? So each one of those. All right. Now what I'm going to do here is I'm going to go up and I'm going to change the center diameter to 65. Now you notice that on any of these you can go in and set minimum max values, all right, that'll be displayed. So basically you'll know what's happening in the HUD based upon these values that you've got set. But I'm going to go down here, type in 65, and I'm going to hit apply. And down here on the lower right hand corner, you're going to see that my barber pole was back, and it's actually updating my roundabout. All right. Now, I'm going to go down here, and I'm going to open up the first leg or arm of my roundabout, and I'm going to select on it, and now my graphic changes. So now if I go up here to my approach, all right, here's my design speed. All right. Here's where I set my lanes and my lane widths. Okay. If I go into my entry, it's got my entry information. If I got my exit, all right, my splitter island, if I want to create one, I can pick on splitter island. If I want to create a crosswalk, I can pick here and turn it on and have it actually create a crosswalk for me. All right. I can do rumble strips, and I'm going to go ahead and do a speed striping. So I'm going to go to speed striping. I'm going to select it, use the default values, and I'm going to apply, and it's going to draw the speed striping in. All right. Now, if I go down here a little bit farther, down to my heads-up display, this is what controls how that heads-up display that we've been talking about works. All right. So this tells you to show the leader lines. All right. And this says, well, this is what's being displayed in that heads-up display. Okay. If I go down here to my 3D corridor, this is how it knew to create the alignments, the updated alignments, to create the profiles, to create the corridors, to update the corridors if anything changes. So these were those default values that we were talking about earlier, okay? It also has the ability to do signage, to put roadway signs in, and also roadway markings in. So if you don't want those, you can just uncheck them and they would not be displayed in your drawing. We'll leave them on for now, okay? All right, so now I'm gonna go ahead and let's see, let me just double check on my speed striping, make sure I've applied it. And now I'm going to hit close to close the box, and sometimes it'll take about 30 seconds to close the box. All right. So it's starting, and there we go. And now you can see it's closed. So the first thing you notice is now going back at, it's updating my corridor model, it's updating my vehicle tracking junction in there. All right. Let me hit escape to clear it out. And now what you're going to see, all right, is you're going to see that I still have an error there. Now by making it smaller, I've caused an error in R3 and V3 on this leg. All right, and I've now caused an error. I'm getting close to an error on this one here. And then on the last leg, you can see I have an error there. Okay, so you can see that by going into the basically editing the properties of that vehicle tracking junction, all right, then I'm editing the actual roundabout both in the junction and also in the corridor modeling that it's done. Okay, now another thing, if I go in and I select on this vehicle tracking junction here, you'll see that there's a lot of grips that pop up. So now if I hover over a grip, this one says I can adjust my near side radius. So instead of doing it through the, through the tables, I can just grip it and drop it and update it that way. All right, I could go down here and I could update my splitter radiuses. All right, I could go over here and hover over this one here, and I could adjust the circulatory lane width. So you can see that I got all these different grips that allow me to basically grip edit this vehicle tracking junction, which will in turn update my corridor model. All right, so that's what I wanted to show you there. Now, what I'm going to do now is I'm going to go ahead and I'm going to pick on this here, and I'm going to pull it down. Right, and I'm going to zoom in a bit, and like we did with the intersections, and I'm just going to drag that down, all right, and match it up to my new roundabout. All right, I'm going to hit escape, and I'm going to go over to here, and I'm going to grab this one, all right, and do the same thing here. Now, this particular assembly here probably is going to have a little work done to it on that particular region of that corridor, right? Because it may not have any daylighting in it, so it's not going to match up exactly. Let me go down to the last one here. Now, this one here, when I was actually splitting that corridor into multiple regions, I didn't back it off far enough. So let me back it up, all right? And then I'm going to select that grip, and I'm going to move it up, and I'm going to pop it into there. All right. Now, what I want you to notice here is you'll see that we've got those little triangles, and it tells you the road lane width is too large. All right, and it's giving me a greater than or less than arrow, saying it's greater by 0.19 feet. All right. So those are those little warnings that we were talking about. So you, as the designer, the engineer, will then have to go in and adjust these properties up to make this design meet whatever design restrictions that you may have. All right. So that's how you create a roundabout in Civil 3D. Now, the last thing that I want to show you is that when it created that roundabout, these are all the assemblies that were created for the creation of that roundabout. Once the roundabout is created, you can go to any one of these assemblies and modify them. And when you modify those sub-assemblies in those assemblies, it will automatically update the roundabout, just like it would with a corridor or an intersection. All right, so there we go. So now we have a roundabout created in our drawing. All right, let's move back over here and let's talk about creating a cul-de-sac. Now, in Civil 3D, there is not a cul-de-sac design tool. So we're going to create a cul-de-sac using a baseline. Okay, now corridors have a hierarchy. Okay, so at the top of the baseline, all right, that contains alignments of the profiles of the feature lines. Each baseline can contain one or more regions. And the regions, of course, will contain our assemblies, okay? Our corridor baselines are controlled through the parameters tab within the corridors properties dialog box. Okay? Now, a baseline can represent the center path of a corridor or the lines for the curb intersections or a cul-de-sac. It's based on the alignment, that's the horizontal component, and a profile, which is a vertical component. And as we know, a corridor again can contain more than one baseline, and a baseline is made up of more of one baseline region, and each region can have its own assembly. Okay, so what we're going to do here in this cul-de-sac is we are going to add a baseline to our corridor. So let's jump back over into Civil 3D. All right. So now in this drawing, I have an alignment, which is a curb return alignment. So if I pick on it, it is called ascent place, ascent cul-de-sac. So if I go to my alignments and I expand out curb return alignments and I pick on ascent cul-de-sac, you'll see that it has that, and it also has a vertical piece, which it has a design profile. Okay. All right. I also have, of course, my alignment for my corridor model in this case, which is called ascent place. Okay. And I have a corridor, all right, which is called ascent place. Now, on this particular example, we are going to be using an assembly that was already created when I created an intersection on our last visit, right? And it was one called a residential curb return left, which looks like this here. And it's made up of a lane, all right, a curb and gutter, in this case, a link width and slope. And this lane is the lane that we can use for targeting. Okay. So what we're going to do is we're going to select on this corridor. Right. And I'm going to go up here and I'm going to say add a baseline. All right. The alignment I'm going to use is going to be my ascent cul-de-sac. The profile that I'm going to use, and you can see it highlights it, is going to be my ascent cul-de-sac DGN. And the assembly I'm going to use is the one that I showed you called the residential curb return. So I'm going to hit OK. And then it's now going to add that baseline to my corridor. And it's going to basically go in and using that assembly around, using that alignment around that. Now, what we're going to do here is we're going to go up to our corridor properties. Okay, I'm going to go over to my ascent cul-de-sac, all right, and I'm going to go over to my targets. All right, now in my targets, for my width target, I'm going to go over here and I'm going to, where it says none, I'm going to select none, and I'm going to go down and I'm going to select on that ascent place center line alignment. That's going to be my target for that lane to extend to. All right, I'm going to hit OK. All right, now I'm going to go up here to my frequency. So how often do I want to do it? I'm going to go up here and tell it that I want to use both, and I'm going to say 5 feet, and I'm going to bump my mid-ordinance distance down to 1.25. So I'm going to hit OK, and now I'm going to hit OK, and if I did everything right, there is a cul-de-sac. So that's how you design a cul-de-sac in Civil 3D using a baseline. All right, pretty simple process. So we created this curb return alignment, and then we created the design profile for it, and then we assigned to that assembly, and then we added that baseline to this existing corridor, and then we adjusted all our targets and our frequency, and this was the result. All right, let's look at the time. Looks like we have time to do this. So here's a bonus for today. We're going to create a knuckle. All right, and that's another condition that you may have. And so basically a knuckle is a bump out that's kind of like a widening maybe on the back side of this bulb. Now, we're not going to use a baseline for this. We're going to use the existing alignment that we're going to target one of those sub-assemblies to. Okay, so let's get back into the drawing. All right. All right, so in this drawing here now, I've got my ascent place. If I pick on this here, my ascent place corridor, okay? And then I also over here, I have an alignment, which is a curb return, which is my ascent knuckle. So if I go down to my alignments, under curb return alignments, all right, so if I go down to my ascent knuckle, you'll see that this one here does not have a profile, so we're just going to be targeting to that. Where the last one, when we did the cul-de-sac, we had a profile that we could have targeted to. All right. All right, so now if I think about it, let me just jump back over here to my cul-de-sac and let me just double check on that and make sure. All right, so I go to my corridor properties, all right, and if I go over here to my target, yep, you see on my outside elevation target, I did not target my elevation. So on my elevation, I want to go out here and I want to pick on that one called the ascent cul-de-sac. That was a step that I missed, and I apologize to that. All right, So when I hit OK here and I hit OK here too, now what I have is I have my, I'm using that elevation for that assembly to go up and down around the outside of that design of my cul-de-sac. So I apologize, I forgot that one step, so I wanted to make sure that you saw that. All right, so let's go back over here to our knuckle now. All right, so now what we're going to do here is that we are going to split this region, okay? So what I'm going to do is I'm going to select on this corridor, all right? And I'm going to go up here to split a region. And I'm going to say that this is the area in my corridor that I want to split. So I'm going to pick that as a region to split. All right, and here's where I want to start the split at, right here at this transition. Okay, then I'm going to go over here and say I want to split this region again right here, and then I want to split it right about, if I can find it now, right about, we'll just say right about there. All right, now I'm going to hit escape, and I'm going to go up here to say edit targets, and I want to make sure that here's my before the knuckle, here's my knuckle, all right, and here's what's going to become after the knuckle. Okay, so now I have 3 regions. We're only going to be working on this region right here. All right, so I'm going to go up here to my corridor properties. All right, and I'm going to do a little cleanup work here. So I'm going to go up here to this one, because it's always best to make sure that you know what your regions are. So I'm going to just call this one knuckle, and this one here I'm going to go down and I'm going to rename it to after the knuckle. Okay, all right. Now the area that I'm going to be working at is going to be the knuckle. So I'm going to go over here and I'm going to pick on my target. All right. Now my target is going to be on the left-hand side. All right. So I pick my width target for my lane super elevation, AOR. I'm going to pick none, and I'm going to target that alignment that I've got, all right, which was going to be called the ascent knuckle. All right. Now on this one, I don't have an outside elevation target like I had in the cul-de-sac. All right. So I don't have to set that like I went back and showed you that I had to set just a second ago. All right. So I pick OK. All right. And now I pick OK. And I'm going to go here and clear my actions, all my events. And now I have a knuckle. So the steps that I use in this is I had an existing alignment. In this case, it was a curb return alignment, all right, that I took this corridor and I broke it up into multiple regions. I renamed the regions. I went to the knuckle region, and then I basically targeted to that alignment, all right, that one lane, and this was my end result. So what we've done here is that we have created 3 things today. We have created a roundabout using the roundabout tool. All right. We have created a cul-de-sac using a baseline. Right. And then that baseline had a design parameter into it, a DGN for the vertical component in there. So it had a profile. And then we attached a assembly to that tracked around that alignment, and then we targeted to the center line of that, in this case, ascent place corridor model. And then we created a knuckle, and the knuckle was based upon that same corridor model that we broke into multiple regions. We worked on the knuckle region, and then we basically targeted that one lane to that alignment that we had created. So roundabout, cul-de-sac, and a knuckle. So this is what we've completed. So roundabout wizard, cul-de-sac using a baseline, and creating a knuckle by targeting to a existing alignment that was in the drawing. So questions? So I'll turn that over to you, Alan. Any questions?
All right, perfect. Yes, first one that came in here, and feel free to continue to send these questions over. Does changing the roundabout properties change the roundabout style?
No, you're changing the roundabout properties is just going to change the properties of the roundabout. If you want to change the roundabout style, then you would have to go in and change the actual roundabout style.
Okay, perfect. Another one that came in here, can you create a cul-de-sac that is not perfectly centered? Do you add a knuckle to a cul-de-sac?
You could probably do any of that, but again, everything that we did there, it's based upon, in this case, we had an alignment with a design profile. So whatever that alignment is set up to do, and then the target where you're targeting the center of that, in this case, that one lane that was being targeted back to the center line alignment, basically just however you have things drawn, that assembly is going to track, that subassembly and assembly is going to track around that alignment using, or that baseline that we created and added to that corridor model. It's just going to track around that alignment. It's going to go up and down based upon the design parameters in that design profile that we've got, and it's going to use the assembly that we've assigned to that. So you can basically, whatever you draw, you can create.
Okay, perfect. Another one is vehicle tracking included with Civil 3D.
Vehicle tracking is not included with Civil 3D. That's part of the AEC collection. You used to be able to buy the vehicle tracking by itself, but a few years ago, Autodesk added that to the AEC collection. So if you have a plain seat of Civil 3D, you would have to upgrade to the AEC collection in order to have the actual vehicle tracking application. But remember, the vehicle tracking piece of it that's inside of Civil 3D is a subset of the Autodesk vehicle tracking. Okay, so and that subset includes the ability to create the corridor model. The vehicle tracking by itself doesn't have the ability to create a corridor model. That's part of what's inside of Civil 3D.
All right. Another one here, do I need to have vehicle tracking installed to create roundabouts in Civil 3D?
No, you don't. Again, same rule applies because the vehicle tracking component that we're using in Civil 3D is a subset of vehicle tracking. So when you install just a standalone, Civil 3D, not part of AEC collection, you still have the capability to create roundabouts because that's a tool set that's provided in Civil 3D. If you have the AEC collection, same thing, you're installing Civil 3D, which has that subset of vehicle tracking in there. It just has that additional thing that you can install the Autodesk vehicle tracking application separately, and that program runs outside of Civil 3D. But plain Civil 3D or the Civil 3D that you installed as part of the AEC collection, both of those have the Autodesk vehicle tracking component subset already built into it so that you can create roundabouts.
Okay, perfect. I'm not seeing anything else right now, so let's go ahead and jump over to that last slide and we'll go ahead and close out.
So let me just say again, thank you for attending the seminar. Thank you for attending all three of our seminars. And today's again was designing a roundabout and modeling a cul-de-sac, and with a little addition of how to create a knuckle in Civil 3D. So again, I thank you for attending.
Okay, thank you all so much for being here today. Actually, one more question did come in. Let's roll it back here. Okay, how do you know if you have AEC? Doug, you want to take that one, or I'm happy to answer it as well?
I mean, I can take it. I mean, basically, you'd have to, if you're a small shop and it's just you or a couple of people, when you buy your software from the reseller, in our case, DDS CAD, when we sell you that, we're going to ask you, do you want AEC collection or do you want standalone Civil 3D? You can also go to your subscription, log into your Autodesk subscription site. And if you have just plain Civil 3D, it's just probably just going to show Civil 3D as a product that you can download and install. If you have the AEC collection, it's going to have about 16 different products, including Autodesk vehicle tracking and Civil 3D that you can download and install.
Correct. Yeah, that page is manage.autodesk.com if you want to check that out. And if you click on products and services on the top after you've logged in, like Doug said, if you see a long list of all kinds of different things, you've got more than likely the AEC collection. All right. And just to close here as well, thank you all for being here today on behalf of DDS CAD. If you have any questions, concerns, anything like that we might be able to help you with, you can reach us at 305-445-6480 or email us at info@ddscad.com. And of course, we look forward to hopefully more presentations in the future. Okay, thank you all so much for your time.
Thank you all.